Sometimes the worry just sits heavy on my chest.
Lean on me then. We'll face it together.
What if I told you that medieval villages, which seem chaotic and haphazard to us, were actually designed so carefully that modern engineers could learn a thing or two from them? We are used to imagining them as disorderly groups of huts standing wherever they happen to be built, but this is an illusion created by movies and novels. In reality, every turn in the path, every distance between houses, and even the direction in which the roof faces were the result of cold calculation and centuries of survival experience. These settlements were born not out of creativity, but out of necessity. The village had to be protected, easy to move around, and resistant to seasonal winds and floods. Houses were built so that they did not cast shadows on each other in winter, so that rainwater drained away through natural channels, so that the wind did not tear off roofs, and so that smoke from stoves did not stagnate in low-lying areas. Even the distance between houses was not determined by chance. It was calculated so that in the event of a fire, the flames would not spread instantly, but also so that heat from neighboring buildings would not be wasted. Watch the video to the end, and you will learn why the shape of the roof was more critical than the thickness of the walls, how woven structures distributed the load better than stone, and how primitive technologies allowed entire villages to survive winters that would seem absolutely unbearable to modern people. What if I told you that everything you believed about medieval villages is untrue? The popular image paints a picture of a disorderly jumble of buildings that sprang up without any plan. In reality, what appears to us as chaos was the highest form of organization, refined over generations. At the heart of this system was the principle of maximum concentration of resources and effort. Houses were deliberately built very close to each other, sometimes right next to each other. This was not a consequence of a lack of space, it was a deliberate move. Adjacent walls heated each other, creating a thermal buffer that saved precious fuel. In a world where winter was a long ordeal, every degree saved counted. The narrow streets, which seem inconvenient to us, also served an important function. They minimized the open space that had to be crossed in inclement weather. More importantly, they created a barrier to the biting winds. The curved rather than straight structure of the street broke up the airflow, preventing it from accelerating and cooling the walls of the houses. Neighbors were not just people living nearby, but partners in survival. They jointly repaired fences, looked after common property, and helped each other in everyday matters. The psychological comfort of such closeness should not be discounted either. In a world full of uncertainty, the feeling of a neighbor's elbow provided a sense of stability. Knowing that you were not alone, that a few steps away from you lived people like you, struggling with the same difficulties, was a powerful source of moral support. This logic also applied to farm buildings. They were often attached directly to residential buildings. This solution not only allowed tools and supplies to be kept close at hand, but also created an additional insulating layer. The wall separating the living quarters from the barn was protected from the direct effects of the cold. Thus, the medieval village appears to us as a model of rational design. It was built not for parades, but for life. Its shortcomings, from a modern point of view, were its main advantages in the context of that era. We are accustomed to judging the past from the height of our technology, but it is worth considering the conditions in which these people lived. They created a sustainable and efficient living environment using only what nature provided them. And in this, they achieved remarkable skill. I'm very interested to hear your point of view. What do you think about such dense construction? Was it a brilliant solution or a necessary measure? Write about it in the comments, and don't forget to subscribe to the channel. Are you ready to learn the truth about what was the real center of medieval life? We sometimes think it was the main street or the market, but in fact, the center of the entire settlement was the water source. The well or stream that provided the village with clean water determined the location of every house and every building. It was not just a convenient piece of infrastructure, but a key factor for survival. The location of the water source primarily determined where the house would be built as well as the entire way of life in the village. It was not the market or the main street, but the water source. Without it, even the most prosperous settlement could not exist. Water was the basis, the foundation of life, and it was around it that the entire structure of the village was built. Without a reliable source of water, life was impossible. The location of the well or water source was the first and foremost factor determining the location of the entire village. The well was located in the center of the settlement, and all paths led from it. It was a real landmark for the locals, and all the routes they used in their daily lives converged on it. A well was rarely private. It was the heart of the community. It was a place of unity and mutual assistance, where there were no barriers between people, regardless of their status or position in society. All paths led to it, and it served as a natural gathering place. Everyone passed by the well on their way there, and the villagers met there. The well was a kind of gateway to the world of information and communication. On their way there, people not only exchanged news, but also helped each other with everyday issues.
If the rains hold off, we should have a good yield.
Here, issues related to common work were resolved, goals were set, labor was shared, and what to do about this or that matter was discussed. It was not just a functional element of the settlement, but also a place for joint action that helped strengthen the bond between people. People started their day by fetching water for cooking, washing, drinking, and other needs. The simple act of drawing water became an important ritual in everyone's life. It ensured that basic needs were met, allowing life in the village to continue. The location of the well in the center of the village also had practical significance. Access to water was important not only for convenience, but also for safety. The village had no water pipes or convenient water distribution systems, so placing the well in the center made it accessible to everyone. Reducing the distance that had to be covered with heavy buckets saved energy and time, two of the most valuable resources. Especially on days when there was a lot of work and little time, saving energy was a significant advantage. Protecting the water source was a top priority. Water was a vital resource, and its purity ensured the health of the entire village. The pioneers understood that even the slightest contamination of the well could cause an epidemic. Protecting the water was not just a job, but the responsibility of every member of the community. It was often fenced off to prevent contamination. This was the first line of defense. The fence around the well not only protected it from contamination, but also prevented accidental falls or debris from falling into the water source. The fences were monitored as carefully as the condition of the houses themselves. This was a critical element of water safety and cleanliness. The fence prevented contact with animals and other contaminants, ensuring the preservation of a clean source. A canopy could be built over the well to protect it from precipitation. The canopy helped protect the water from dirt, debris, leaves, or mud that could get into the water during rain. The canopy not only protected against rain, but also served as a shelter for those who drew water in rainy weather. It was an extra layer of protection that extended the life of the well. I will reveal the most closely guarded secret of medieval builders, which is almost completely forgotten today. We think that stone and brick are the best materials, but in the Middle Ages, they knew something we don't. They built living walls that literally breathed, and this was their main weapon against the cold and damp. We are talking about the technology of wattle and daub, wattle and clay. The basis of such a wall was a frame made of sturdy wooden posts. Thinner stakes made of flexible wood, such as hazel, were driven vertically between them. These stakes were then woven together with horizontal rods like a basket. This woven frame was called wattle. It was incredibly strong, yet flexible. The wall could withstand minor deformations in building settlement without cracking, unlike rigid masonry. This was especially important for houses built on unstable ground. Then came the daub, a clay mixture. It was not just clay. Binding components were added to it: crushed straw, grass, or other plant fibers. These fibers reinforced the clay, preventing it from cracking as it dried and giving it tensile strength. This mixture was applied to both sides of the wicker frame, filling all the voids tightly. The straw in the mixture also acted as a heat insulator. It created myriads of air pockets in the clay, which significantly reduced the thermal conductivity of the wall. The most ingenious property of this material is its hygroscopicity. A wall made of wattle and clay had the ability to absorb excess moisture from the air in the room and release it back when the air became too dry. This created a natural and healthy microclimate inside the house. Unlike modern airtight housing, such a house breathed. There were no problems with condensation or stagnant air. This constant regulation of humidity was the key to feeling warm. Dry air is much easier to heat than damp air. After drying, the clay was often covered with lime whitewash. This was not only a decorative move. Lime is a natural antiseptic and additionally protected the wall from moisture and pests. The white color reflected the sun's rays, preventing the house from overheating in summer. This technology was incredibly resource efficient. All the materials for construction could be found literally underfoot. Wood for the frame and rods grew in the nearest forest. Clay lay in the ground, and straw remained after the harvest. Building such a house did not require complex equipment or high qualifications. Almost every family knew how to use this technology. It was truly a folk, accessible, and ingeniously designed architecture. Like this video if you are also surprised by such ingenuity, and be sure to subscribe to the channel so you don't miss new videos about how people survived in the Middle Ages. Guess how long it took to create the main element of a medieval house? The answer is the entire life of a tree. We are talking about the cruck frame technology, which was the backbone of medieval dwellings. This structure was not just a set of beams, but a whole philosophy of construction. The essence of the method was to use two massive, naturally curved logs. They were obtained by sawing a large tree trunk lengthwise. These two halves, called blades, became the main load-bearing pair. They were installed opposite each other and connected at the top, at the ridge of the roof. Together, they formed a perfect arch, or the letter A. This arch took on the entire load from the roof and transferred it directly to the ground. This was the main secret. The walls of a house built using this technology were not load-bearing. They only served a protective function, shielding from wind and rain. All the work was done by the internal skeleton of curved beams. This had enormous advantages. First, such a structure was incredibly stable. It could withstand strong winds and heavy snow on the roof. Second, it allowed for the creation of a spacious interior free of internal partitions. Special trees were needed to make these arches. They were often selected and even shaped in the forest many years before being cut down. The master carpenter had to have incredible intuition to see the future support for the house in a crooked oak trunk. There were several such arch pairs in the house. They were installed at a distance of several meters from each other. Then they were connected by longitudinal beams, purlins and ridge beams. The rafters and roofing material were laid on this frame. The cruck frame technology was especially popular in regions rich in forests. It allowed for the most efficient use of wood. Instead of cutting straight beams from massive logs, builders used the natural shape of the tree. This was not only economical but also very durable. The wood fibers in a curved beam ran along the bend rather than being cut across, as in a sawn beam. This made the part many times stronger against breaking. Building such a house was like assembling a giant construction set. All the parts were prepared on the ground and carefully fitted together. Then the entire structure was lifted and fastened with wooden pegs. Not a single metal nail was used. What other material besides wood could achieve such strength and flexibility? In the next chapter, we will learn where they got such material and how they managed not to run out of wood. We often think that medieval people thoughtlessly cut down forests, but this is a profound misconception. In fact, the survival of the village depended directly on the forest, and the attitude towards it was far from careless. The forest was not just a source of firewood and building materials. It was a strategically important resource that was treated with great care. For each settlement, the forest was an integral part of life and was used rationally to ensure survival for many years to come. It was important not only to harvest wood, but also to ensure the renewal of this resource, which allowed nature to remain in balance. Without competent forest management and long-term planning, no village could survive for long. The survival of the village depended directly on the forest, and it was not just a source of firewood and building materials. The forest served many functions. It provided shelter from the wind and cold, a source of food and a place to hunt. The forest was a place where peasant life could flourish, where people could gather berries, mushrooms, and other gifts of nature. Understanding how to manage the forest properly was vital. After all, cutting down trees thoughtlessly, without regard for the future, could lead to the depletion of resources and a decline in quality of life. The entire layout and life of the village depended on the ability to use the forest as a long-term resource. It was a carefully managed, renewable resource. Medieval people understood perfectly well that the forest was not an endless supply, but a finite resource that needed to be cared for. Unlike the modern approach to forest exploitation, villages at that time used methods that allowed the forest to recover after each felling. The forest management system was very sophisticated and required regular intervention to maintain a balance between logging and regeneration. Without competent forest management, no village would have lasted 100 years. Unlike the predatory approach to nature, which can lead to the depletion of resources, medieval people used methods that allowed them to preserve the forest for future generations. Cutting down trees was not simply an act of destruction, but part of an overall strategy aimed at maintaining the sustainability of forest ecosystems. These forestry practices supported not only the villages, but also their immediate surroundings. A key method was coppicing, or coppice forestry. This was an ancient and very effective way of working with the forest, in which trees were not cut down completely, but were cut at ground level. Thanks to this, the trees continued to live, producing new growth, and the forest retained its structure and health. Carpenters and peasants did not cut down trees at the root to kill them. They acted in such a way that the tree would produce new shoots that could be used for the needs of the village. This made it possible to obtain wood regularly without destroying the forest itself. Each tree became part of a long-term resource that provided for the settlement. Thus, with each passing year, the forest remained just as fertile, and the trees continued to produce new shoots. This also allowed for the preservation of tree species diversity, which contributed to the strengthening of the ecosystem. With this technology, the forest continued to grow, providing the village with everything it needed, but did not disappear. In the spring, young shoots began to grow from this stump. These thin shoots, which reached for the sun, quickly gained strength and length. Depending on the type of tree, after 5-15 years, these shoots reached the required size and could be cut again. Cutting did not destroy the tree, but gave new shoots that continued to live and develop. This allowed the forest to regenerate, and the village continued to obtain wood without disturbing the natural balance. This method was not only sensible, but also ingenious for medieval forest management. Dozens of thin, straight shoots stretched toward the sun. These shoots served as the basis for future timber harvesting, and each one was valuable to the village. The shoots provided materials that were used for a variety of purposes, from construction to weaving. After a few years, the cut shoots turned into useful materials for construction, and the shoots themselves continued to grow, supporting the vitality of the tree. This process was endless, and the forest always remained alive and useful to people. Using the forest in this way ensured its preservation for many generations to come. Depending on the tree species, after 5-15 years, these shoots reached the desired size and were cut again. This cycle allowed the village to use its forest resources efficiently and not waste them. The stump remained alive and produced a new crop. Thus, the forest continued to grow and develop, even though the cut wood was used for various needs. This provided the settlement with the necessary supply of wood without depleting nature. The forest became a self-renewing resource. The pioneers knew that skillful forest management would help ensure sustainability for many years to come. This process was the basis of forestry, and it became an important tool in the struggle for survival. This technology was ingenious. It combined practicality, durability, and respect for nature. Using coppicing, the pioneers were able to take full advantage of the forest without destroying it. It was a harmonious use of resources that allowed the village to develop and maintain stability. This method had been tried and tested over time and was perfectly suited to the conditions of a medieval village. It provided a constant supply of wood that was available at any time. It allowed for an endless supply of wood of the required caliber to be obtained from the same area. The same tree could continue to produce useful shoots several times. This made the forest not only a source of raw materials, but also a self-renewing resource. Thin and flexible hazel rods were used to make wattle for walls. These materials were light and easy to use. They could be used for a variety of purposes, from construction to fencing. What if I showed you how the medieval climate control system worked? Every house had one, and it was the roof. In an era when heating was a luxury, the roof was responsible for 80% of the heat retention in the house. Its design and materials were thought out down to the smallest detail. The most common material for roofs was straw or reed. Today, this seems like something that is flammable and short-lived. But for medieval people, it was a high-tech insulating material. A thick layer of straw, laid in the right way, was practically impervious to water. The secret was in the laying. Bundles of straw or reeds were attached to a wooden frame, starting from the bottom edge of the roof and moving upwards. Each subsequent layer overlapped the previous one, creating a scaly structure. Water ran down the straw without penetrating inside. But the main property of such a roof was thermal insulation. The thickness of the straw covering could reach 30-40 centimeters. This massive layer of porous material created an incredible thermal barrier. The air trapped between millions of straws was the best insulator. Such a roof worked like a thermos. In winter, it did not let precious heat from the hearth escape outside. In summer, on the contrary, it did not allow the scorching sun to heat the room, keeping it cool inside. The roofs were made very steep, with a large angle of inclination. This was not for beauty. The steep slope forced water and snow to run off the roof as quickly as possible, preventing moisture from lingering and penetrating deep into the straw. In regions where straw was in short supply, wooden shingles or shakes were used. These were thin wooden plates that were laid overlapping, similar to tiles. Such a roof was less warm than a thatched one, but more durable. The roof frame on which the material was laid was also important. It had to be strong enough to withstand the weight of wet straw or snow, but light enough not to put excessive strain on the walls and frame of the house. Roof maintenance was a constant concern. It had to be inspected regularly, holes had to be patched, and the condition of the ridge, the most vulnerable spot, had to be monitored. A good thatcher was worth his weight in gold in the village. The roof structure determined the entire thermodynamics of the house. It was not just a cover for the building, but its main protective and heat-saving element. Its effectiveness directly affected how much firewood would have to be burned in winter and how comfortable life in the house would be. Which roof seems more reliable to you? Straw or wooden shingles? But what good is a good roof if the main source of heat inside the house is not working properly? In the next chapter, we will talk about the heart of the house, the hearth.
It is the hearth inside that
The heart and soul of a medieval home, without exaggeration, was the hearth. It was not just a place for cooking, but the only source of heat and light in the center of all family life. Its location and design were not accidental and met the harsh requirements of survival. In most simple peasant houses, the hearth was not located against a wall, but in the very center of the room. This was an ingenious solution from a thermal engineering point of view. The central location allowed the heat from the fire to spread evenly in all directions, warming the entire space of the house. Such a hearth did not have a chimney in the modern sense. It was a simple place on the earthen floor, lined with stones or clay. The smoke from the fire rose up to the high roof and accumulated under the ridge. This may seem inconvenient, but it made sense. Before leaving the room, the hot smoke gave all its heat to the air and roof structures. It did not fly instantly into the chimney, taking precious degrees with it. Special openings in the gables, trusses of the house, or simply a small hole in the roof served as smoke vents. Often the smoke escaped through gaps in the thatched roof. The thatch itself did not ignite from such proximity, as the smoke had already cooled down by that time. Moreover, this smoke served another important function. It impregnated the roof beams and wattle walls, acting as a natural preservative. Wood treated with smoke became resistant to decay and did not attract pests. Life around such a hearth was strictly organized. Closest to the fire were places for cooking and work requiring light. As you moved away from the hearth, the space became cooler and was used for sleeping or storing supplies. Of course, this method of heating took some getting used to. There was a constant smell of smoke in the room, and soot settled on the walls and ceiling. But that was the price people paid for warmth. The fire itself required constant attention. It was kept burning around the clock, as rekindling it was a laborious task. At night, the coals were covered with ash so that they would smolder until morning. Controlling the fire was an art form. It was necessary to know which types of wood produced more heat and which produced less smoke. It was necessary to constantly monitor the fire to ensure that sparks did not fall on wooden or straw parts of the house. The hearth was not just a technological element, it was the center of social attraction. The whole family gathered around the fire, where they worked, ate, and spent long winter evenings. It was literally the source of life. The layout of a medieval village did not end at its outskirts. It was not an isolated unit, but was inextricably linked to the surrounding agricultural land. Each settlement was part of a wider agrarian landscape, where fields and forests worked for the benefit of the village. It was these lands and how they were used that dictated the shape and structure of the settlement itself. It was not only the location of the houses that was important, but also how agricultural work was organized. The land on which grain was grown and animals were raised was the basis of survival. It was inextricably linked to the surrounding agricultural land. The layout of the village was dictated by the need to make effective use of the surrounding land for agricultural purposes. The entire village was designed so that its inhabitants could easily reach their fields and other resources. The most important element was to ensure convenience for working in the fields, as well as access to water and convenient transport routes. All these aspects were inseparable from each other and created a system where each plot played its role. The location of the houses, as well as the distribution of agricultural land, formed a harmonious and coherent picture. The layout of the fields directly dictated the shape and structure of the settlement itself. Living space and agricultural land were always closely linked. It was no coincidence that houses were located along roads and highways leading to the fields. This provided residents with direct access to their plots of land and convenience for transporting agricultural products. Plots for arable land, pastures, and vegetable gardens were closely adjacent, creating a common network where each part was interconnected. The structure of the village and its fields created an organic connection that served as the stability of the entire community. The most common type of village was the so-called linear type. It was a simple and convenient form of organization, where houses were built along a central street or road, forming a single line. All settlements were usually built along the most important communication routes. This could be a river, a road, or a main street, which made it easy to move around and trade. This village structure ensured the compactness that was necessary for effective interaction within the community. The main farm buildings, such as barns and workshops, were also located here. The linear form was created to bring people together and facilitate access to land plots. Houses were built in 1 or 2 lines along the central street or road. This allowed for the community to be organized, creating a convenient and orderly space for all its members. The positioning of houses along the street ensured that every resident had equal access to essential points, such as wells and marketplaces. People lived close to each other, which allowed them to quickly exchange news, solve problems, and work together. It was a social and practical solution that facilitated better coordination. In such a village, everything was aimed at simplifying the process of communication and collaboration. This street was not just a thoroughfare, but the main axis around which the entire economy revolved. The main road connected all the important elements of the village and organized the space around it. The street could be a place for trade, meeting guests, and also a place for solving common problems. Houses, shops, and workshops where necessary goods were produced were also located here. Homesteads were built around the road, and everything was tied to a single axis in order to make the most efficient use of the available space. This was a principle of rationality that minimized the time and effort required to move around within the settlement. Survival in a medieval village depended not only on personal farming, but also on collective infrastructure. 2 facilities were vital to the entire community: a mill for grinding grain and a communal oven for baking bread. Their availability and proper organization solved several critical problems at once. The mill, whether water or wind-powered, was one of the most complex and expensive structures in the area. No single family could afford to build and maintain it on its own. Therefore, it was a collective facility that served the entire village. Its importance cannot be overestimated. Turning hard grain into flour is the basis of all nutrition. Doing this manually with hand mills was incredibly difficult and time-consuming. The mill freed up this enormous resource, allowing people to do other things. The location of the mill was dictated by nature. Water mills were built on rivers, often some distance from the village, so that the noise and dam would not disturb the inhabitants. Windmills were erected on the highest hill in the area so that they could catch any wind. Another important facility was the communal oven or bakery. In many villages, residents were not allowed or advised to have large ovens in their own homes. This was due to the enormous fire hazard. The dense wooden and straw buildings could catch fire from a single spark. Having multiple hot ovens in every house was a recipe for disaster. Therefore, bread baking was centralized. One large solid stone or adobe oven was built. It was located in a specially designated safe place, often on the edge of the village or in the central square. All residents used this oven in turn. The presence of these two objects, the mill and the oven, was a sign of a developed and stable village. They showed that the community was capable not only of surviving on an individual level, but also of cooperating to solve complex common problems. This infrastructure was as much a part of rational planning as the layout of the houses. It reduced risks, saved resources, and made everyday life more predictable. It was a technology of collective survival in action. In conclusion, it is important to understand that a medieval house was not just a collection of separate elements. It was a unified, holistic system designed for one main purpose: to conserve heat. Every component, from the foundation to the roof ridge, worked in conjunction with the others. It all started with the orientation of the house. It was almost never placed randomly. As a rule, the house was oriented with its long side facing south to north. This allowed the blank north wall to take the brunt of the cold winds. The south side, on the other hand, was made more open. This is where most of the small windows in the entrance were located. This allowed every precious ray of the low winter sun to be captured, which helped to warm the room. The windows were very small. Today we appreciate large panoramic views, but in the Middle Ages, each window was a huge hole through which heat escaped. There was no glass in simple houses, so the openings were covered with wooden shutters or oiled cloth. The small size of the windows was a compromise between the need for light and the task of retaining heat. The shutters were closed tightly at night and in bad weather, turning the house into an almost airtight capsule. Doors were also designed to minimize heat loss. They were made of thick, tightly packed boards. Often there was a small vestibule in front of the entrance, or simply a heavy curtain that blocked the flow of cold air. The interior space was unified. The absence of partitions allowed heat from the central hearth to circulate freely throughout the entire volume. Zoning was achieved not with walls, but with fabric curtains. These curtains, made of thick linen or hemp, were hung around the sleeping areas. They created a kind of room within a room, a small enclosed space that quickly warmed up from body heat. It was a simple but very effective system of local heating. The floor in the house was often just earth. This was not a sign of poverty, but another element of thermoregulation. The earth, which is below the freezing level, always has a stable positive temperature. It served as a natural heat accumulator. Thus, we see that the medieval house was a true engineering marvel. The curved frame, breathable clay walls, thick thatched roof, central hearth, and thoughtful orientation all worked as a single mechanism. It was the architecture of survival, perfected. We can see that the medieval village was far from being a chaotic and primitive place. It was a complex, rationally organized system where each element had its own specific purpose. From the location of the well to the angle of the roof, everything was subordinated to the main goal: survival and heat conservation. The people of that era, without our technology, created an incredibly efficient and sustainable living environment. They learned to breathe in unison with nature, using its gifts wisely and prudently. Their clay and straw houses were not just dwellings, but ingenious machines for preserving life. Their experience teaches us that the simplest and most accessible materials in skilled hands can become the basis for a truly smart home. They prove that a deep understanding of the laws of physics and nature is more important than expensive and complex technologies. Which of these medieval engineering solutions do you find most ingenious? And do you think we could use some of these principles today in our quest for environmentally friendly and energy-efficient housing? Suggest topics for future videos you would like to see in the comments, and don't forget to subscribe to our channel.